Hello everyone, welcome back to Physics Corner. Here we are discussing the previous year questions of Kerala State Eligibility Test in Physics. Today I am going to work out the problems from the last exam. The last exam was in February 2020 and some of you have requested me to work out those problems. Okay, so here we go. First question. Let epsilon 0 denote the dimensional formula of the permittivity of vacuum. If m is equal to mass, L is equal to length, T is equal to time, and I is equal to electric current, then we have to express the dimension of permittivity of vacuum in terms of mass, length, time, and electric current. Okay. So, how will you do that? Normally, what I do is I will just write down the expressions, the basic expressions that I know, which includes the term permittivity here. Okay. So, see, we have the Coulomb force F is equal to, we know that equation, right? F is equal to Q square by 4 pi epsilon 0 R square. Yeah, epsilon 0 is there in this equation, right? And we can write the charge Q as the product of electric current and time, right? Because we have to write the dimensional formula for epsilon 0 in terms of current also, right? So we can write Q as I to T, and from these equations we can write epsilon 0 is equal to Q square by 4 pi f r square, which is equal to I square T square by 4 pi f r square. Okay, now we can write down the dimensional formula for epsilon 0 as epsilon 0 equal to dimensional formula of I square T square by 4 pi f r square. So, I square T square by ml T raised to minus 2, which is the dimensional, ml T raised to minus 2 is the dimensional formula for force, and for R square we can write L square. Okay, so just write down this dimensional formula for all these quantities given in this equation. And 4 pi is a constant and it does not have any dimension. Okay, so we will get a final result as m raised to minus 1, L raised to minus 3, T raised to 4 into I square. It's given in option B. Clear? Okay. Second question. When a soap bubble is given an electric charge, it contracts, it expands, its size remains the same. It expands or contracts depending upon whether the charge is positive or negative. So, we know that a soap bubble has a spherical shape, right? It's a sphere, right? So, when we give an electric charge to this bubble, this charge will spread all over the surface of this sphere uniformly, right? And we know that light charges repel. So, each of these charges will repel each other, and as a result, what happens? The soap bubble expands. Simple, right? So, option B is the answer. Third question. An electron moving around the nucleus with an orbital angular momentum L has a magnetic moment. This is a direct question. We know that it's EL by 2m. Option B is the answer. I think that it does not need any explanation, right? So, we are moving on to the next question. Okay. Fourth question. A charged particle is projected along the direction of uniform magnetic field, then its velocity increases, decreases, remain unchanged, none of this. Actually, here they are talking about the speed, I think. കാരണം ആ ചാർജ്ഡ് പാർട്ടിക്കിൾ ഒരു യൂണിഫോം മാഗ്നറ്റിക് ഫീൽഡിൽ എത്തുന്ന സമയത്ത് അതിൻ്റെ ഡയറക്ഷൻ ചേഞ്ച് ആയിക്കൊണ്ടിരിക്കാം. അപ്പോൾ ഡയറക്ഷൻ ചേഞ്ച് ആവുന്നതനുസരിച്ച് സ്പീഡ് കോൺസ്റ്റൻ്റ് ആയിരിക്കുന്നു, വെലോസിറ്റി ചേഞ്ച് ആവുന്നു എന്നാണ് ശരിക്കും പറഞ്ഞത്. പക്ഷേ ഇവിടെ അവർ മാഗ്നിറ്റ്യൂഡ് ഓഫ് വെലോസിറ്റി, ദാറ്റ് ഈസ് സ്പീഡിനെ പറ്റിയിട്ടാണ് അവർ മെൻഷൻ ചെയ്യുന്നതെന്ന് തോന്നുന്നു. അതുകൊണ്ടായിരിക്കണം സി ആണ് ഓപ്ഷൻ തന്നിരിക്കുന്നത്, റിമെയിൻസ് അൺചേഞ്ച്ഡ്. ഓക്കെ. So, fifth question. The instantaneous magnitude of the electric field and magnetic field vectors in an electromagnetic wave propagating in vacuum are related as E is equal to B by C, E is equal to C into B, E is equal to B by C square, E is equal to C square B. It's also a direct question. Option B is the answer. E is equal to C into B, right? Okay, sixth one. If lambda v, lambda x and lambda m represent the wavelengths of visible light, X-rays and microwaves respectively in a given medium, then which one of these is correct? Okay. Option B is the right answer. Because it's also a direct question. You have to be familiar with this regions of electromagnetic spectrum. Look at the picture. Region with shorter wavelength is given in the left side, and in the right side you can see longer wavelength region. Okay, so you have to remember this order. Okay. Seventh question. A rocket ship is 100 meter long on the ground. When it is in flight, its length is 99 meter to an observer on the ground. What is its speed? Here you have to remember the length contraction. Okay. The proper length is 100 meter is given. Okay, and the contracted length is also given as 99 meter, and we have the equation for length contraction as L is equal to L0 into root of 1 minus V square by C square. L0 is the proper length and L is the contracted length. Okay, so from that expression we can find out the speed. V is equal to root of 1 minus L square by L0 square into C. And after the substitution of these values into this equation, we will get the result as 4.2 into 10 raised to 7 meter per second, which is option A. Now moving on to the eighth question. A proton has a kinetic energy of m0 c square. What is its momentum in units of mega electron volt per c? Okay. Here we have to calculate the momentum of this proton, right? So we can write down the expressions for relativistic energy as E is equal to square root of p square c square plus m0 square c raised to 4. And we have another equation, E is equal to m0 c square plus, that is the resonance energy plus kinetic energy. Okay, and here it is given that kinetic energy of this proton is m0 c square. So when we substitute into this equation, we can write E is equal to m0 c square plus m0 c square, which is equal to 2 m0 c square. And we have equations 1 and 2. And we can equate these equations as 1 is equal to 2, which will give 2 m0 c square equal to square root of p square c square plus m0 square c raised to 4. So after doing all these operations here, we will get the final result as p is equal to, final expression as p is equal to root 3 into m0 c. And mass of proton in terms of in units of mega electron volt is the value is 939 mega electron volt, and we can substitute into this equation and we will get the final result as P is approximately equal to 1630 MeV per C. Okay, so option A is the answer. Ninth question. The propagation constant K of the de Broglie waves associated with a body of rest mass m0 moving with velocities v is, the de Broglie wavelength can be written as lambda is equal to h by p, where p is the momentum. Okay, and we can write the momentum, relativistic momentum, as p is equal to m0 v by root of 1 minus v square by c square. And propagation constant k is expressed as 2 pi by lambda. And when we substitute the value for lambda, the expression for lambda, we can write k as 2 pi p by h. And again we are substituting for momentum p, we will get k is equal to 2 pi m0 v by h into square root of 1 minus v square by c square. Option C is the answer. 10th question. The de Broglie wavelength of a 15 kiloelectron volt electron is 0.10 angstrom, 0.20 angstrom, 0.30 angstrom and 0.40 angstrom. Here also we can talk about de Broglie wavelength, right? So lambda is equal to h by p, and it's also equal to h by root of 2 me, and the energy is given as 15 kiloelectron volt, and we are substituting the values for h, which is Planck's constant, and m, which is the mass of electron, which is equal to 9.1 into 10 raised to minus 31 kilogram, and energy is given in kilo electron volt, right? So we have to convert it into joule, into the units of joule. So 15 into 1.6 into 10 raised to minus 19, and we have 15 kilo electron volt, right? So it's 15 into 10 raised to 3, right? So that's why I have written as 1.6 into 10 raised to minus 16 here. Okay, so after the substitutions and after the calculations, we will get de Broglie wavelength lambda as 0.10 angstrom. Okay, option A. We can work out the other problems in the next video. So if you have any doubts, you can just comment and prepare well for the exam. Thank you.